question, but we'll do some of those in a bit. So here we've been given our original function. So without even having to think, we're just going to go ahead and find the derivative. So how do we do that? Well, we use the power rule. The number that is in the exponent is multiplied to the front. So we have 3 times 3 is 9. Then we still have an x, and then we minus 1 from the power. So we had 3 before. So we're going to get 3 minus 1, which will give us 2. And we'll do that to each of these terms. So the next one is negative 2x squared. So again, we take the number in the exponent to multiply to the front. Negative 2 times 2 is negative 4x, and then 2 minus 1. And the next part, we have 4x. So the exponent here is 1, right? X to the power of 1, because we don't write it. So 1 times 4 is 4. And then, well, technically it's 1 minus 1, right? And at the end, we have a minus 1. So we have a constant. Yeah, so just make sure that you guys remember here, if we have a number by itself without x, that means that this is just going to be 0 in the derivative. So let's write it all out with the numbers deducted for the exponent. We're going to have 9x squared minus 4x to the power of 1, but we don't need to write a 1, right? Because that is the same as here, the blue one. And then we're going to get plus 4. And now it would technically be x to the 0, but anything to the power of 0 is 1. And what I want you guys to kind of remember here is that when you guys see something that has just an x, that means we're just going to take the number in front and the x disappears. Okay, once we have this is our derivative, and this is already half of the work done for you guys to get an achieved mark. Yeah, remember, you always have to find the derivative and then do something with it. Now, for this question, they're asking you to find the gradient when x is 1. So just always remember that the gradient function is the derivative. So if we want to find the gradient, all we got to do is substitute in numbers into our derivative. So we're going to have g prime evaluated when x is 1. So that means we're just going to replace the the x with a 1 for each of those parts. So let's do that over here. Okay, so we're going to go 9 times 1 squared minus 4 times 1 plus 4. And you guys have a calculator in the exam. So all you got to do, if you're not sure, you don't have to solve anything in your head. So we're just going to go ahead and plug exactly that into the calculator. If you want to, you can also do the brackets. Yeah, so we're going to get 9 times 1 squared. Well, 1 squared is 1, so 9 times 1. Why is it not writing it? Excuse me. Number block. Oh yeah, there we go. That should work now. So we're going to have 9 times 1 squared. Yeah, I mean, I'm just doing this so you guys know what to do. This is obviously a question you guys can do by yourselves, even in your head. There we go. And the answer is going to be 9. So what does that mean? That means that the gradient now at the point x is 1 is equal to 9. And that is everything you guys need to do. This is the final answer to get an achieved mark over here. Okay, let's have a look. We're going to do a couple of examples, but of course much faster. So this is now saying find the gradient of the curve, and they have again been given you y. Yeah, so this is an indicator for you guys. This is the original function. We need to have a derivative. It's either the derivative or the antiderivative that you guys need. So without even having to understand the question, technically you can already go ahead and just do the derivative, because that's where the marks are in this paper. Yeah, but why would we do the derivative here? Because the derivative is the gradient function. Every time we talk about a gradient, we want to do the derivative. So dy by dx, you can also write y prime, it doesn't matter what you write, is equal to, and then again, we're going to do the same rule. the 3 is multiplied to the front. 3 times 2 is 6. Copy the x and then reduce the power by 1, so we get 2. Next part, we're going to have a negative 9 multiplied by 2 gives us a negative 18. X has a 2 on top, now it has a 1, but I don't need to write that. And then the next part, if you guys remember, that's the one I spoke about earlier on. If it's just got the x, that is the one that just drops the x. You can kind of think of 1x disappears in the step each time. And if there's just that 1x, then it goes away. So we're going to have plus 12. And in the end, we have a number. Yeah, this is your constant. Yeah, remember that whenever you have a number, that disappears. So technically plus 0. And that's already half of the question done. So we have the derivative is 6x squared minus 18x plus 12. And now again, the first part is to find it. The second part is to do something with it. So what do we want? We want to find the gradient. Yeah. So remember that this here is our gradient function. Technically, that will give us the gradient here. So we just need to use the equation in order to find the gradient. And the question here has x's in it. So it's the formula in terms of x. So if we want to use it, we need to use x. So we're going to substitute x. And then again, well, let's have a look what x is. We need to understand how this works, but I'm pretty sure you guys will remember this. This is the x value and the y value. So in this case, x is 1. So we're substituting in x as 1 over here. And then we're going to get 6 times 1 squared minus 18 times 1 plus 12. And we can just go from there. 1 squared is 1 times 6 is 6 minus 18 plus 12. And it looks like that should be 0. There we go. So what does that mean? This means that at this point, the gradient is 0. Finding the answer that m is 0 will give you guys the achieved mark here. Yeah, same style question that we had before. And now for all the people who are watching this later on after the live stream, yeah, make sure that you guys are pausing the video, giving these questions a go. We want to make sure that every single person passes this exam at the end of the year. Okay, now let's have a look. I think we're just going to be very quick with this question. Again, we have a function h that is given to us 5x cubed minus 7x squared plus 3x plus 6. And it's asking us to find the gradient when x is 3. So again, we're talking about the gradient. So what do we need to do? We need to find the derivative and then use the fact that x is 3. So we're going to do that a little bit faster. Yeah, so if you guys are doing this from home later on, make sure you guys are pausing it. So multiplying the power to the front, 5 times 3 is 15. Reduce the power by 1. Next one, 2 times negative 7 is negative 14. Power was 2, now it's 1. This is a term that just has an x in it. Remember the one with just an x in it, the x kind of disappears. Yeah, or you can do 1 times 3 and then the power becomes 0. And again, guys, what happened there? Sorry about that. What about the 6 here? This is the constant term. Yeah, so there is no x in there. That just disappears plus 0. And what do we need to do in order to find the gradient? Well, this is the gradient function. So the gradient is h prime of the x value. So we substitute in 3. So we're going to get 3 squared times 15 minus 14 times 3 plus 3. And I'm just going to do dot, 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 because I know you guys can put this in the calculator and figure out the answer. Okay. If you guys are watching this later on from home, here's another example of a very similar style question. We're not going to do this one today, but this is just so you guys have more exercises that you guys can do. I'm just going to go and blend these in. These are all from past papers. Yeah, so these are very accurate of the achieved questions that you guys are going to get. Right, okay, the next style question that you guys need to know is how to find the original function for a derivative. So remember, we have the original function and the gradient function. The original function is the one that does not have a prime over here. So whenever you see a question where we have been given the derivative, at least in this year, you guys are basically going to have to find the original function. Yeah, so here we can see we want to find the function f, but we have been given the derivative f prime. Yeah, so if we have f and f prime, in order to get to f prime, we need to derive, we take the derivative and anti-derivative the other way around. Yeah, so very good. Now, how do we actually do this? Well, we're going to use the same rule that we have done for differentiation, just the opposite way around. So f of x is equal to, we're going to look at this term by term, and we're going to use the rule for the power. Yeah, we can start with this last one. Actually, it doesn't matter which order. Yeah, I'll write them in the same order though, just so it looks better. Now here we're going to raise the power by 1. Yeah, that was the last step. We're going to raise the power by 1 to make it 3. And then we're going to divide by the new power. So that is 3. Yeah, so this is the last term over here. Yeah, so again, we raise the power by 1 and then just divide it. And you can always just write it as a fraction. That's the easiest. You don't have to actually do anything. Just write it as a fraction. Your calculator can do the rest anyway. Okay, let's do that one more time for this part over here. Yeah, now we have a -2. Yeah, so we had a -2. Now x had a power of 1. We're going to raise the power by 1. 1 more than 1 is 2. And again, we're going to divide by the new power. There we go. And we're basically done. Now we just need to do the last step over here, which is the one with the no x term. Now, this one here, yeah, if you guys remember from doing the differentiation just now, that comes from the one that just has the x. Yeah, it's kind of like every term is gaining another x term. So if we don't have an x term, we're going to just add that term. So if it's a number, it gains the x by itself. Technically, it would be to the power of 1 divided by 1. So the same rule that we've been doing this whole time still applies. And of course, there's one more thing that you guys need to worry about, and this is for finding the original function, and that is the plus c at the end. Yeah, it is required that you guys have a plus c at the end every single time you guys find the original function. Now, every time you have a plus c, you need to ask yourself, do I have information to actually find that c? And what do we need? Yeah, so in order to find c, we need another point. Yeah. And this is important that it's on the original. Yeah. We need another point, an x and y point from the original. Both in x and y are needed. So they have actually been given here. So we're going to use the fact, yeah, 2,6 is the point that we've been given. And the reason why is because we can just think of this as being the x value and this the y value. So we can substitute in the x's over here and over here and over here. And the y value is our f of x. So if we are now going to just put all of those in. Oh, thank you, cat. Thank you very much. Okay, so if we're going to substitute them all in, then we're going to get 6 for f of x, that's our y value, is equal to 8 times 2 minus, and you guys can, you don't have to simplify this. You can just leave it exactly like this. There we go, plus c. And now what we're going to do, sorry, so you guys can see, there we go. All we're going to do is we're going to go and chuck this whole thing in the calculator. Yeah, of course, we're going to have the plus c that we still need to figure out using a little bit of algebra, but the majority of it is calculator work. So we're going to go and have a quick look at that. Let me turn on the calculator. There we go. And we're just going to type in exactly what the question says, 8 times 2. And now minus, and again, you guys can just copy it exactly like it is. No, oh, why does my thing not work? Okay, let's try that again. 8 times 2. Is it working? Yes. So 8 times 2 minus, and we can just put this all in a fraction. Yeah, no simplifying needed. 2 times 2 squared. Yeah, divided by 2. And so on. Yeah, I'm going to simplify it a little bit while I put it in the calculator just to make it a little bit faster. But technically, I want you guys to remember that you guys can just put this into the calculator exactly how it is. No, nothing needed. So 3 times 8 over 3. Okay, and once we have all of this, we're just going to press enter. Yeah, nothing needed. 6, and we have 6 equals to 20 plus c. And now it becomes a very easy algebra question that you guys should be able to answer. How do we find c? We need to get rid of the 20. 20 is added to c, so the opposite is minus, so minus 20 on both sides. So we're going to get c is negative 14. Okay. Why can't you guys see negative 14 on the screen? Of course, today everything is not working. Sorry, guys. I'll just get that back on. Otherwise, how are you guys going? While I reconnect my device, let's have a look. Have you guys already had your mock exams for this? Wonderful. There we go. We are back. Perfect. So C is negative 14. Now, basically, this is all you need to get your achieved mark. But I always tell all my students to make sure that you write down your final answer at the end. So our final answer here would be f of x is our equation, which is 8x minus 2 over x squared over 2 plus 3x over 3 over 3 minus 14. Yeah, just so everyone knows what your final answer is. Okay, let's have a look. Let's do another question very similar from a different paper with the same type of question. Again, when we read this, we have been given that g prime is this equation here. And again, if you guys struggle with passing, just remember that you are always asked to find the original or the gradient function. So if the gradient function is given, then we're going to find the original. But again, remember here they're asking for g, which is the original. So that's why we're doing antiderivative here. So we're writing g of x is equal to, and we're going to go backwards and use the same rule. 10 doesn't have an x, so we're going to add it. Minus 5x, so what we're going to do, we're going to write minus 5. X, we're going to raise the power by 1, which makes a 2, divide by 2, and we're going to leave it exactly like that, and we're done. Next term, 2x squared, so we're going to write 2x, but now the power is 1 more, so it's going to be to the power of 3, divided by the new power, which is 3. Very good, and we're done. And guys, remember, every time you find the original function, you guys have to remember a plus c. Yeah, always remember the plus c. And as soon as you remember that you need the plus c, you then automatically know that you need to find what the value is for c. So how do we do that? We need 1 point, and we've been given 1 point already, which is 1,4. So let's substitute everything in. Yeah, remember, x is the first value. Okay, so minus 5 times 1 squared over 2 plus 2 times 1 to the power of 3 over 3 plus c. And what goes over here for g of x? Well, remember, at whatever the function value is, that's always our y, so that's going to be 4. And again, guys, don't stress about this one. Just check it in the calculator. Yeah, I'm going to do the calculation here manually probably, but yeah, you guys can just put that in the calculator. We're going to get 10 minus 5 over 2, and then we're going to get 2 over 3 plus c. And because we have fractions, let's just chuck it in the calculator. I don't have to do that with you guys. You guys have a calculator ready. Yeah, so easy peasy. So same thing, we're going to do 10 minus, yeah, there we go, 5 over 2 plus 2 over 3. Enter, and it's going to get us a number, and preferably we want this as a fraction, but it doesn't really matter. You can write it as a number perfectly fine. 49 over 6 plus c. And now the last thing, we want to know what c is. So we're just going to do one step, minus 49 over 6 on both sides in order to find what c is. So we're going to get an answer for c. And again, we can just do that in the calculator as well. So 4 minus, and then the answer button. Now you guys have it much easier on the calculator. I need to click on it manually. And just to make it easy for you guys, I'm just going to write minus 4.167. Yeah, so it doesn't really matter if you leave it as either a decimal or a fraction. I usually recommend my students to have a fraction as the answer, but in the end, it doesn't matter. You guys will get your mark as an achieved as soon as you have found this c value, and you guys have used algebra and shown, calculus to show that this is the original function. Okay, awesome. Welcome everyone to the stream. Yeah, let me know if you guys are enjoying this and how you guys are doing with your mock exams, if you've already had those. Also, if you guys want to move on to some different type of questions, yeah, then we will. Now, we've now done two things. We've found the gradient function and substituted in values to find our gradient. We found the original function and solved for c. All of those are achieved questions, and just like before, I'm just going to slide them through. So for all of you guys who are watching this later on YouTube, or for those who want to come back to it and do some practice, just go and do these questions. They're exactly the same as the ones that we've already done. Okay, so to the next style question that we have for the achieved level. And there's always going to be one or two of these questions in your exam. So when it says sketch, we're always going to be given a coordinate system, and we're asked to draw or sketch the other part. And remember, this is not the graphs topic, so accuracy is kind of meh. They don't mind it too much, but what they do worry about is that you guys know the difference between the gradient function and the original function. So make sure that you guys know how to do this one. It's a kind of step-by-step guide. Yeah. So what I'm going to do is I'm going to write down the rule or the step-by-step guide over here as we talk and discuss it together. So the first part is you guys need to figure out which function is on the top. Yeah. So in this, it says below is the function f of x. So again, we see there's no dash, right? So we know that the original function is on the top, and we're going to be finding the gradient function at the bottom. Now, there's two ways to do these questions, and I'm gonna just give you guys a first way of doing this. This is the go-to method, and there's gonna be a way for you guys to get better marks from the same question if you guys are following them from a different perspective. So let's start with the first one. The only points that we really care about are the following. We want to know when we have turning points in the original function. Yeah. So here a turning point would be this point over here. Yeah. So what we're going to do is at every turning point, and remember, I'll write it down here. So all turning points Yeah, so identify all turning points. And what we're going to do is we're going to have the gradient is 0 at that point. Yeah, that's a very important fact that you guys need to remember. So the gradient is 0. That means we are going to go through the x-axis at that point for our question. Yeah, for the gradient function, it goes through that point because the y value here is 0. Okay, so the second part that we are going to check, yeah, is increasing and decreasing. So I always like to do two different things. I'm going to write arrows for the original function. So for example, like this, yeah, this would be increasing and decreasing for our original function because that's what the function is doing. And then I'm going to use a plus and a minus for those, and maybe I'll put it over here, plus and a minus, because remember, when we're increasing, that means we have a positive gradient. And if we're decreasing, we have a negative gradient. Yeah, so this top part is used for the original, and the bottom part is for our gradient function. Yeah, so, and once we understand this, we can easily draw these. So here I can see before the turning point, we are going to be decreasing. That means decreasing is minus. So on our gradient function, we're going to have a negative. After the turning point, we're going to be increasing. That means we have a positive. So now all we got to do is we're going to have a look at this point here where we are going through 0. After this point, we need to be in the positive numbers. Below that, before that, we need to be in the negative numbers. And that is the indicator, yeah, that we can now draw our line. So, oh my God. There we go. Yeah. So now this is the first method that I would say you guys need to know for majority of these. Yeah, about 80% of these. All you got to figure out is where are the turning points, the maximums and minimums. That means that in the gradient function, we have 0. So we have an x-intercept. And then you figure out, is it going to come from the bottom and go to the top? Yeah, and you do that by checking if it's increasing or decreasing before. Now, there's an exception to this. And the exception here is that sometimes they give you two types of equations, a straight line or a parabola. Those are the only ones that you guys have to remember that there's a special rule for you guys. And let me see. We're going to come back to that one after the next example. Yeah, we're going to practice this one more time, making sure that we remember these. And then I'm going to show you guys the other way to get yourselves higher marks, often rather easy merit and excellence questions. So let's have a look over here. Yeah, we're going to do exactly what we did before. Yeah, let's try and remember what we had. So the first step was we need to identify the turning points, TP. I'm just going to make it very short, yeah, so I'm not spending so much time writing. So where are the turning points? Well, one of them is over here, and one of them is over here. So what does that mean? Well, we can kind of make a little line down here. If you guys have a ruler, I don't. Yeah, but that means that at that point, we have what? We have an x-intercept. Yeah, at the turning point, the gradient is 0. So we're going to get a x-intercept for our gradient function. And just to make it proper, yeah, remember we had the original and the gradient function over here. Yeah, so sometimes they switch them around and they ask you to do it the opposite way. So we've already marked our turning points. The next part is just to figure out where we are increasing and decreasing. I'm just going to do a plus and a minus. So we go to the original one. The original question is going to get the arrows because that shows us if we're going up or down. And then in the bottom of the graph, we're going to get a plus or a minus. Yeah. So here we're going up. So that means we are going to be in the plus. After the turning point, we're in the negative and then again in the plus. And now all we're going to do is we're going to go to this graph, and before this turning point, before it, we are going to be in the positive numbers. So somewhere here. So all I'm going to do is make a little line there, preferably with a pencil so we can rub it out. After the turning points, we have to be in the negative numbers. So I'm just going to make a little line through there. Then again, for the next point, before we were in the negatives, and then we are in the positives. So now with a little pencil, I can go over it with my hand. It looks like it's somewhere, something like this. Yeah. And once we know what the shape is, then that's when we kind of just like get rid of what we drew in pencil, and you guys need to use your pen in your exam, and we're going to do exactly that. And now it doesn't matter if you guys are drawing it like this, which looks a little bit awkward because it's hand drawn. That's perfectly fine. Also, if you guys are not sure, how it works, let me get rid of this one here. If you guys draw it like this, that is also a pass, perfectly fine. The thing that is in the marking schedule is the shape, if it's going to be a U going up or U going down, so this would not be allowed, because then we're not following the plus and the minus that we have. Both the green and the blue will give you guys full marks here. One is for shape and the other one is for the turning points. They are a must. Let's have a look at this question over here. We have find the rate of change at a specific time. We've been given a question or an equation in terms of t. Now, when I say rate of change, they basically mean the gradient, but the variable is time. So it's basically the same thing as if this was a p of x and so on, with x to the power of 3 instead of the t and so on. So the rules don't really change. So what is it asking for? It's asking for the rate of change where the population is decreasing on day 10. Well, let's have a look. If we are decreasing, that of course means we're negative, but we will get to that answer once we just put everything in. Rate of change means gradient. So every time we find the gradient, we're just going to find the derivative. So p of t, but prime. And again, we multiply the power to the front, 3t squared, reduce the power by 1, minus 60 times 2 is 120, t, plus 768, and then plus 0. There's no x value for the last one, so that's 0. So this is now our rate of change. And if we want to know what this is at a specific time frame, then we can substitute in t is equal to 10. That is day 10. And you can see this because t is given as the number of days. Okay, so let's substitute that in. We're going to get p of 10 prime is equal to 3 times 10 squared minus 120 times 10 plus 768. And we're going to put this into the calculator, and then we'll have the answer. Okay, so let's grab that out real quick. We need to go back to our main menu, of course. So 3 times 100 minus 120 times 10 plus 768. There we go. We're going to get minus 132. So this is the rate of change. So getting to this part here will give you guys an achieved mark. Again, remember, we want to be able to find the derivative and do something with it. Find the original function and find the c value. There's always 2 steps for you guys to get it achieved. Now, this question is basically the same as the first one, right? Where you guys had to find the gradient at a certain point. This is exactly the same thing. We find the derivative, substitute it in the value, and we're done. And here's another question for you guys who are watching this later on. You guys can try this one and let me know how you guys get on. Make sure that you guys are liking the stream or commenting below if you guys have any questions. Helps me out a lot. Okay, the last achievement style question that you guys need to know about is to find the coordinates where the gradient is given. So again, let's have a look here. We have h of x is given. That's the original function. And now what we want is we want to find the points when the gradient is equal to 3. So again, we're talking about the gradient. So every time we talk about the gradient or rate of change or any of those, what do we need to do? Well, we need to know the gradient function. So we're going to have to do the derivative. And again, a little cheat code. Remember, they give you an h of x here. So in the calculus paper, you probably want to then just do the derivative. So let's do that. And you guys can use the calculator. 2 times 0.25 is 0.5. Reduce the power by 1. The one with the x just drops the x, and the number at the end plus 4 is 0. Okay, so what's the next part? Well, here we still need to substitute in, but now it is given to us, yeah, that the gradient is 3. Yeah, so we've been given that the gradient is 3, not x is 3, not y is 3, but the gradient is 3. Well, and again, what are the two things that you need? Find the derivative and do something with it. Yeah, those are the 2 steps for most of the achieved style questions. So what are we going to do? Well, we have to substitute in the 3 here, but the question is where? Yeah, it's not x, so we can't substitute in for x. But remember, this here is our gradient function. So this is where we need to substitute in the 3. So we get 3 is equal to 0.5x minus 2. And well, it's asked for the coordinates. So we have now got an equation in terms of x. So we can solve this. Yeah, you guys can use the solver in the calculator, but at this point, I would expect that you guys know how to solve these linear equations. So plus 2 on both sides. So then we're going to get 5 is equal to 0.5x and divide both sides by 0.5 or multiply both sides by 2. Doesn't really matter, it's the same thing. And you have a calculator, so you can just easily do that. Then we're going to get x is equal to 10. Excuse me. But now the last point is, yeah, the question is very clearly asking for a coordinate. And a coordinate is a x, y value. So we need to write it in that brackets form. And in order to find the y value, well, where do we find the y value from? It comes from the original function. So the original function was h of x is 0.25 x squared minus 2x plus 4. So how do we find the y? Well, remember that the y value is this part over here. Yeah, the function value. So we're going to find this by substituting x. We have x now from the part before. So we're going to substitute in 10 in order to find this. And again, you guys have a calculator, so you guys can just do that. So this is going to be 25 minus 20 plus 4 is equal to 9. So we have found that the value for y is 9, and our final answer would be 10,9. Finding this part over here is an achieved mark, and therefore one of the last achieved style questions that you guys need to know about. Yeah, and I'm just going to blend these in for everyone on YouTube. Make sure that you guys are pausing the video, trying these out for yourselves. Go back and follow exactly the same steps that we have done if you guys want to do this for practice. Yeah, remember, you guys learn math by doing, not by watching. You guys need to be actively practicing. And I think this is it. Yeah, there's, I think, one more question. Yeah, one more question, very much to the same style. And these are every single achieved question style from the last 5 years in NCEA. So if you guys are able to answer every single question today, you're basically guaranteed to pass this paper. Yeah. So if you guys struggled with any of the questions, yeah, this is mainly for the people watching it later on YouTube. Make sure that you guys go back, try the questions again, come back tomorrow, try the questions again, and watch what I'm doing. Follow the steps. Make sure you guys are remembering. Right, watch out, kitty. Here we go. Wonderful. Awesome. And with that, that will probably be the end of today's stream. Yeah, so today we went through all the different achieved style questions for the NCEA Level 12 calculus paper. Yeah. If you guys liked the video, especially on YouTube, make sure you guys like and make sure you guys are subscribing, especially over the next upcoming weeks. I will be uploading a lot more short videos with a lot more practice examples that will basically cover all the things you guys need. Hopefully I can get most of the videos done before the NCEA exams. Otherwise, I'll see you guys next week again at 5 o'clock every Friday for more level 2 exams. Also,